Hey y'all, welcome to Miss Clarke's chemistry class. We're going to jump right into electron configurations. So electron configurations are a good way to show how electrons fill into the sublevels, the energy levels, and the orbitals. So electron configurations are going to be the new way that we show electrons instead of just placing them in the energy levels around the nucleus. Before we can do electron configurations, there's 3 rules. We're going to really just talk about one for electron configurations. Aufbau is a German word that means building from the bottom up. So the Aufbau principle means that electrons fill from the lowest to the highest energy levels. The closest energy level to the nucleus has the least amount of energy. As we go out, more and more and more energy. That's why they hold more and more and more electrons. Let's talk about how you can create your own Aufbau's principle cheat sheet on your paper anytime you need to, because I bet you have to have it memorized. So if we list all the energy levels with the sublevels in order, 1s, and then remember the second energy level has 2 sublevels, s and p, so we have 2s and 2p. The third energy level has 3 sublevels, s, p, and d. The fourth energy level also has 4 sublevels, S, P, D, and F. And we're only going to go as big as F, but I'm going to let you know it really does get bigger. So energy level 5, same for 6, the same 4. 7, we're going to show those same 4, S, P, D, and F. S can hold 2, P can hold 6, D can hold 10, F can hold 14. It doesn't go in order. Here's my little trick though. If you lay all these energy levels and sublevels out in order, then you draw diagonal lines to show you the order. So we're going to start with the first line. This is going to show the order of filling. So 1s, then 2s, then 2p and 3s, then 3p and 4s. Yes, we're going to go to 4s. Yeah, I'm noticing we still have 3d. That's because d holds 10 electrons, s only holds 2. 10 is greater energy. Let's keep going. So after 4s, we've got 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p, 6f, 7d, and really and truly, you're going to stop right here at 7p. So let's see what that looks like all in order. In the correct order according to Aufbau. So if we're reading that little chart and we're going to show the order, we would start with 1s. And since s holds 2, I went ahead and put a superscript of 2. Let's quickly look at that order. Are you noticing right there I got out of order? That's what I'm talking about. It doesn't go in chronological order. So if we're using Aufbau's principle, you see that we start with 1s2 and you just keep following those diagonal lines until you get all the way down to 7p6. Let's actually do some electron configurations. Let's look at magnesium. Magnesium is number 12 on the periodic table. And since this is neutral magnesium, it has 12 electrons. So if we're going to follow Aufbau's principle, so the electron configuration for magnesium would start with 1s2. And then if we build from the bottom up, we're going to go to 2s2. That's 4 electrons. So we're going to keep going. 2p6, that's 2, 4 plus 6 is 10. We only need 2 more. That's going to take us to 3s2. This is the electron configuration for magnesium. Our second example, bromine. Bromine is number 35 on the periodic table, and so it has 35 electrons. Again, we got to start from the bottom up. So we start with 1s2, 2s2, that's 4, 2p6, 3s2, that's 2, 4, 6, that's 12. After 3s2, we've got 3p6, 4s2, that takes us to 20, 3d10, that's 30. So we only need 5 more. Remember, P can hold up to 6, but we only needed it to hold 5. So we're only going to place 5 electrons in this 4p orbital. So that's our electron configuration for bromine. So there may be a little bit of confusion because energy levels can hold more than 8 electrons, but according to the Octet Rule, atom's valence shell is full with 8 valence electrons. So that really doesn't make sense. Always the largest energy level is going to come from S and P. S holds 2, P holds 6. You got it, 2 plus 6, that's 8. That's where the Octet Rule comes from. So you see, electron configurations, they look pretty difficult. In fact, I like to leave them on my board when my students come in. Kind of freaks them out a little bit. But then once they learn how to do it, they're like, Miss Clarke, that was so easy. And it is. If you agree, press the like button. Leave me a comment and let me know what your biggest challenge is. I bet I can help you find a shortcut for that. Don't forget to subscribe. Bye, y'all.